Welcome to the ET322 how-to video for the Transistor driver lab, building it in Multisim. Okay, so what we're going to do is we're going to calculate our collector resistor value. Okay, and we're going to use Ohm's law and some information. So we're going to have RC equals VCC, which would be 15 volts, minus, we'll say 1.4 volts for our diode. And we want our diode to light at 20 milliamps, so we're going to divide it by 20 milliamps. And let's break out our calculator here, and we have 15 minus 1.4 equals divided by 20 second EE minus 3, and I have 680 ohms. Okay, so what we're going to do is we're going to calculate our collector resistor value. Okay, and we're going to use Ohm's law and some information. So we're going to have RC equals VCC, which would be 15 volts, minus, we'll say 1.4 volts for our diode. And we want our diode to light at 20 milliamps, so we're going to divide it by 20 milliamps. And let's break out our calculator here, and we have 15 minus 1.4 equals divided by 20 second EE minus 3, and I have 680 ohms. Okay, so what we're going to do is we're going to calculate our collector resistor value. Okay, and we're going to use Ohm's law and some information. So we're going to have RC equals VCC, which would be 15 volts, minus, we'll say 1.4 volts for our diode. And we want our diode to light at 20 milliamps, so we're going to divide it by 20 milliamps. And let's break out our calculator here, and we have 15 minus 1.4 equals divided by 20 second EE minus 3, and I have 680 ohms. Okay, let's build our flasher circuit. So let's disconnect our base resistor. Let's flip them. And of course we flipped them in a knot. Let's go ahead and let's flip them again. There we go. Alright, so we're going to go to our power sources. And we're going to pick signal sources, and we're going to do a clock voltage. We're going to put a TTL signal on this, so we need to flip this guy vertically so we get the plus going in. We're going to borrow a ground. Oops. And let's flip him vertically. Okay, and 0 to 5 is good, but what we want is 10 hertz, and Multisim doesn't always resolve this based on computer time. So let's see what we got. 10 hertz, 5 volts, and let's get rid of our probes and close this out, and let's fire it up, and we should be flashing. And that's probably more than 10 a second, but It is flashing, and we have a flashing circuit. Okay, let's rebuild our circuit here, and we're going to use the existing parts. Let's just go ahead and swap this guy out. Replace, and let's go to PNP and get a 3906. Alright, so we're going to go ahead, and we need to, let's go ahead and cut all this out. Okay, so we're going to take our diode and we're going to flip them. Once we disconnect them, we're going to flip him vertically, because now we're going to use a minus voltage for our PNP. Okay, and let's get rid of our clock circuit. Yeah, so we have 680 needed. Okay, good. And now we're going to change our VCC up here to a minus 15 volts and reconnect it. Because the PNP is going to require minus voltage. And so let's go ahead and fire it up. And we have a lighted circuit. Okay, let's revise this circuit to be a positive circuit using a PNP. We need to reverse our resistance because now we're using a positive voltage. So let's flip him horizontally. Oops. Vertically, sorry. And we're going to ground this base resistor. 15, it says 510, we'll use 680. Whoop, we forgot to flip the transistor. Okay, let's flip this guy vertically. So now we have our emitter at top. And let's see if we can get it to work. Okay, let's build our voltage divider circuit for NPN. So let's grab some grounds. Let's grab a VCC. Let's grab a ground. We need a 3904, sorry. Transistor, NPN, 3904. And we need some 1K resistors. We need at least 3 of them here. And I need a 10K potentiometer. And this one, what we're going to do here is we're going to make a variable voltage divider here, so we could figure out, we want to figure out a few things. So let's flip this thing horizontally. That's going to feed. What we're going to do is we're going to adjust the base current and figure out when this transistor turns on. This 1K is to protect the resistor in case we go too far. Okay, let's make this 15 volts. And let's zoom in. And let's put an ammeter in here. Okay, circuit built. What we're trying to do with this circuit is build a voltage current chart for our transistor. So first thing we want to do is figure out the voltage to emitter voltage. So we need another collector to emitter. Okay, and we want to set this guy at 0. And our transistor should be fully off, which means that we should get the maximum voltage on here. So let's make sure that we have everything set up, and we do not. Okay. Good. So let's turn it on, and we should get our 15 volts. Good. 15 nanoamps, that's almost 0. So what we calculated here is our collector to emitter voltage on our transistor. Good. Now let's go up until we get maximum current and 0 voltage. So let's start move up. And we should be getting eventually 5 milliamps and almost no voltage. So let's check a look at our circuit here. We've got 1K, 1K, 15 volts. So our current through this should be about 7. Okay, so that's going to be our collector current. Okay, from our IC and our VCE max, we're going to plot our load line. Now what we're going to do is we're going to try to find the midpoint where this thing is biased properly. So let's go ahead and okay, let's keep going down. Let's see here. Let's try to get 7 volts on that dude. There we go. Okay, so now we found our midpoint. We have 7 volts on our VCE and 4 milliamps. So that should plot out on our chart, and this is where we want this to be biased in order for it to become an amplifier. So we're going to put some AC on here and put capacitors in order to get this to be a amplifier transistor.